Okay. So, good morning, everyone. We've made it to Wednesday. We're halfway through our lines and angles problem-solving section. So, I'm going to go over the answers to the previous problem set, which I'll be honest was not entirely problems. There were a few exercises mixed in there to get things rolling. Tonight's set, though, is much more problem-based. It comes from the latter. I think if you watch, like, all the numbers were like less than 20, and so these ones will be more. So usually the later problems tend to be a little more larger and involved, and so there's fewer of them for you to do. They'll be much more problem oriented, okay? And require you to really apply those techniques. All right, but since we have nothing else that needs to be done today, I'm going to give you maximum time to work, which means I need to get started on going over answers to the other one. So here we go. Problem set 1 started off with how many different line segments appear in the figure? Name them all. So you're looking for segments go from end point to end point. So from A to B, right? And A to C, and we stop there. So you have 10 in total. Here are their names. It's every possible combination of the letters. It's basically the handshake problem, right? AB, AC, AD, AE, BC, BD, BE, CD, CE, DE. You never have to repeat one because AB is the same as segment BA, so you can reverse the name at any point. Okay. Next up, finding the distances. Okay, looking for distance, which on the number line usually comes down to some kind of subtraction. Okay? Although in this case you could end up subtracting negative numbers, which turns into addition. So you can't forget that. That is, you know, it seems like elementary level. You know, maybe you did this in like 2nd grade or something. Even maybe before that, but yeah, it's very critical for building up that basic element for geometry because we got to measure all kinds of things. So there are the measurements each here: 4.34, 1.91, 6.65, and 4.22. This is a distance. It's never going to be negative, just amount of space from one end to the other. Okay, number 9. Now we have the angles. Can you name all the angles here? So there are 3 possible angles. There's this BAC, or you could go backwards, CAB. And then there's BAD, you can go with the large one, or CAD, the other small one. And as a pair of adjacent angles, you would need BAC and CAD. Of course, you can reverse their names, so if you want to swap this one for its likeness, you can do that as well. As long as the A stays in the middle. The vertex always goes in the middle. Otherwise, the order does not matter. Any questions on this first page? No? All right, then. Carrying on. Number 11, how many different angles less than 180? Okay, so we're not talking about going out and around backwards, we're just in here. And you will have 10 different combinations. You know, right, so AOB, and then AOC, and then AOD, E, and then B with all of them, and then C with all of them, right? So it's very similar to the segments question. How many of them are obtuse? You can make 4 different obtuse angles and 6 different acute angles. Number 15, Here we have the classic, here's some angles, find the other measurements. Okay, they give you some measures here, so BFC, that would be 55, AFD, so that guy's 150, right? BFE, this one is 120, and AFE is 180 over there, right? So then we got to calculate, okay, what would be AFB? So you would take this minus that, right? And a little bit of subtraction work there, or actually AFB, you would just take 180 minus the 150, or the 120, sorry. See, I even confused myself. These are, that's the 150, and this is the 120. There we go. Okay, and CFD right there comes to 35. And that would be, now that you know what this measure is, now you can take this and this away from the 150, and the leftovers there. It's the 35. All right, and one more for level 1. The lines across the plane. How many regions can we divide up the plane? All right, 2 lines could make 3 regions, or if you intersect them, you could get up to 4. So the maximum possible comes out of maximizing the possible intersections. So here's a quick chart with each of them because they wanted you to progress. Okay, how about 3 lines, 4 lines, 5 lines? You could probably draw these, okay? Find your pattern that way. But here we have the results for 3, 4, 5, 10 lines. You get 7, 11, 16, 56 regions. And so the general pattern turns out to be n times n plus 1 over 2. Hey, we've seen that before, plus 1. All right, so if we went from 4, 7, 11, you're like, well, that's really close, but 3, 6, 10 would be the triangular numbers. This is 1 more than each triangular number. So I'm telling you, this little formula, n times n plus 1 over 2, okay, it shows up everywhere. The sooner you find that, memorize it, recognize it, oh, the easier life is going to be. Okay. Any questions on those, the rest of the level 1 problems? No? All right, but I'm going to go a little bit faster. Here are the level 2s. There are 8 different rays named here, named very similar to the line segments, except make sure you have the arrow over each end, right? Ray AB is different from ray BA, just because of which end I put the arrow on. I could also have written it as still AB, but put the arrow that direction. That would work as well. But it makes it harder to name it out loud as unique. All right, number 10, 3 different angles have Q as the vertex. Here they are, right? Using either naming order, so PQR, or reverse that, PQS and SQR. And the 2 pairs of adjacent angles would be, you've got to be using these ones in the middle here, PQS and SQR. So this guy and this guy. And PSQ and RSQ, so this guy and this guy. And next up, we have another figure here. How many angles where T, S, and W are collinear? Okay, so that's drawing this figure, so you got to assume this is one straight line. How many different angles can you form? 6 possible different angles. 2 of them are obtuse, and 2 that are supplementary. You could go with WSV and VST, or WSU and UST. Next we have 16. Okay, this figure, we're given, again, some angle measurements. This is perpendicular. So AO is perpendicular to CO, so that there is 90. AOD, this whole thing is 150. And BOD is 72. Without measuring, simple calculation, add, subtract, you can find that AOB is 78 and BOC is left at 12. Same techniques as the, what was the other similar one? Which number was that? This guy, 15. Okay. 18. This one, they don't give you much of the measurements. They tell you the measure of angle 1 is 14 less than twice the measure of 2. And we can see from the figure that they both add up to 90 degrees. So what you have to do is set up a system of equations and solve the system of equations. So the technique here is use a variable. Okay? And you'll find that we round off to the 100th, you'll get 55.33. I like that double there. And 34.67. And then the level 3s included this guy, another distance on the number line, except now we're dealing with radicals here. Okay, something start getting used to. By Algebra 2, we'll be throwing those around like they're nothing. Right? And actually, I think it almost makes it simpler because we don't have to deal with any decimals. It's all multiples of square root of 2. So here are the distances there, 6, 5, 2, and 9 root 2. Number 9, another vague, like describing the relationships between the angles. Here. So A and B are complementary, but A is 4 times as large as B. I would say that's another like clue there to use a variable. Because anytime you have something described as this is 4 times more than this, or this is something less than that, you're like, oh, that sounds like you're saying an equation out loud. So write in some equations, right? Solve the equation. Measure of A must be 72. And similar here, set up a system of equations for x and y. You'll find x is 123 degrees. And 22 now, similar to dividing the plane up with the lines into different regions, we are taking a collinear line, right, and dividing it up with different points, okay? Or actually reverse that. We're taking the points and saying how many lines can we draw, right? So if we make them not collinear, we can get at most 3 lines. So draw more points. 4 points can get you 6 lines. 5 will get you 10. 6 will get you 15. And this is a similar pattern, but not quite. This, for any n number of points, you will get n times n minus 1 divided by 2. Okay, there's the final answer there. Last call for questions from this problem set. All right, problem set 2. Up to you. Have at it. You've got the rest of the day. I'll be on standby to answer any and all questions. It is due Friday morning. Go.